Today we will discuss about the Phasor diagram, which is used in AC to describe the voltage and current. So let us discuss what is Phasor diagram or what is a phasor. When the sinusoidal varying quantities are shown by the rotating vectors, we will take the phasor as a rotating vector. Then this is called a phasor, and the diagram will be known as Phasor diagram, and the vector in this form is called phasor. The quantity may or may not be vector. Here we can take the current as a vector, phasor vector, voltage also phasor vector. These vectors are imagined to rotate with the angular velocity equal to the angular frequency of this quantity. The length of the vectors gives the magnitude of that quantity. The y-intercept gives you the instantaneous value. So phasor diagram is used to compare two quantities. For example, in case of voltage and current in a AC circuit, phasor diagram is used to show whether current is lagging behind or leading. So you see these red lines. We can take a phasor, current phasor or voltage phasor. Suppose we will take this is the current. Graph of current is varying with different times and different angles, and this is the peak value. We will take length of this as the peak value, and it is rotating along the angular frequency of AC. So this red line will be a phasor, and it is rotating with the angular frequency of AC. So we have already discussed about the resistors. In case of resistor, the formula of voltage, applied voltage V is equal to Vm sin omega t, and the current is I is equal to In sin omega t. So there is no angle between them, there is no phase difference between them. So if we draw the vector diagram, phasor diagram, so this red deep black line represent current phasor, and this is dotted lines represent voltage phasor. So length of the dotted line will become V maximum, V peak, and length of the current will represent peak value or maximum value current, and at any time its y-intercept will give you the instantaneous value. So there is no angle difference between the voltage phasor and current phasor for a pure resistor. But if we take a inductor, this is the inductor, so this is AC, we are passing I current through it. So let us discuss mathematically what happened to the relation between current and voltage in case of a pure inductor. AC through a inductor. So this is the symbol of inductor. Suppose this inductor has inductance L, and it is joined to a AC voltage, and V is equal to Vn sin omega t, and I current is passing through it. So we know according to Kirchhoff's law, this voltage applied to here will appear on the inductor. So we can write V is equal to L di by dt. So our aim to calculate current. So cross multiply it. What we will get? Di is equal to V by L dt. Put the value of V. V is equal to Vn sin omega t. So this will be Vn sin omega t by L. So to know the current, what we will do? We have to integrate di. So integrate both sides. So this is Vm by L sin omega t dt. So when we will integrate it, the integration of di will be I. So the integration of sin omega t is equal to minus omega t by omega. We will read in mathematics. So what is the equation? So this is Vm by L into omega. So minus Vm omega L cos omega t. So let us take minus cos omega t. So we can write it is equal to Vm omega L sin omega t minus pi by 2. Because sin omega t minus pi by 2 is equal to minus cos omega t. So let us write this factor as XL. Inductive reactance. It's SI unit ohm. So it is just like voltage by current, a voltage by resistance. So this will gives you current. So here XL is known as inductive reactance. So it depends upon omega and L. So omega 2 pi nu. So it will be 2 pi nu L. It means the inductive reactance depend upon directly on frequency, and coefficient of self inductance of the inductor. So now our equation become I is equal to Im cos omega t. What is V? V was Vm sin omega t. So I become Im cos omega t. So if we will draw the graph, so this line will represent voltage, this red line represent current. This rail line is represent current. So what is the phase angle difference? The phase angle difference between them is pi by 2. So we can say the voltage leads the current by pi by 2, or the current lag behind the voltage by pi by 2. Similarly, let us calculate what is the average power consumed in the inductor. So you know instantaneous power P is equal to V into I. So V is equal to Vm sin omega t. So I will got what is value of I? That is minus Im cos omega t. So this Vm sin omega t into minus Im cos omega t. So this is minus Vm Im sin omega into cos omega t divided 2 multiply 2 because it is in the form of sin 2 omega t. So it is become average power per cycle is equal to minus Vm I by 2 average value of sin 2 omega t. You know sin 2 omega t a periodic function, its average value 0, so we will get 0. So the average power consumed by the inductor is 0. So it means in each quarter half cycle, in quarter cycle it stores magnetic energy, in the next quarter it resupply the energy. So in third quarter again store a magnetic energy, in the fourth quarter it resupply the energy. You see our here this frequency was omega, here in case of power the frequency is 2 omega, so the time period will be halved, ठीक है. So in a pure inductor the average power consumed per cycle will be 0, so we will call a pure inductor is a wattless component, the average power consumed by it is 0. So this is the Phasor diagram. The voltage leads the currents by pi by 2, or the current lag behind the voltage by pi by 2. So these are their waveform. So this is about AC through a inductor. So in the next period we will discuss AC through a capacitor. Again we will draw the Phasor diagram, the circuit diagram. We will calculate the relation between voltage and current and the average power consumed. So in a inductor, if it will store magnetic energy in first quarter, so in the next quarter it will resupply the energy. Similarly, third quarter again store magnetic energy, fourth quarter again resupply the energy. So the average power consumed or average energy stored by it will be 0. So we can say pure inductor is a wattless component. Thanks to all.